Hello everyone, we are a senior design team from the Biomedical Engineering Department, and our project is radiofrequency ablation modeling and validation of unique cannula designs sponsored by Medtronic. I'm North Leithauser.
I'm Joe Caron.
I'm Olivia Creamer.
And I'm Becky Daniels.
Radiofrequency, or RF ablation, is an important medical procedure performed commonly by physicians all over the world. Patients that are dealing with chronic pain can see a physician who will use this minimally invasive procedure to ablate or essentially burn the sensory nerve at a specific location. This will nullify the pain in the patient. All in all, the procedure does not take much longer than an hour, and the results are long-lasting, making this an extremely convenient and useful treatment. We were tasked with working on the probe and cannula design for the Caron RF platform created by Medtronic, as seen in the bottom left-hand image on the screen. We focus on how changes to these designs can affect lesion formation and treatment effectiveness. Now I'll send it off to Olivia to talk about our objectives for this project.
Keeping in mind that we are attempting to increase lesion size, we tested 3 different methods: altering the cannula design to increase surface area and tissue contact, altering the insulation to try to direct the distribution of the ions and heat in the tissue, alter the procedure by adjusting body temp through ice or heat packs, or introducing saline to increase available ions to transfer energy. We started testing through computer simulation using COMSOL multiphysics and got an approximate heat profile. We then modeled the most viable option in NX to get it in more detail. The design that we chose for this was the simulation shown all the way to the right in pictures D and H. We also tested procedural changes on chicken breast that had been heated in a sous vide. We tested the chicken heated to a range of 26 to 38 degrees Celsius and measured the resulting lesion. We also changed the insulation on the tip by using an acrylic insulator painted on in different patterns. Lastly, we tested ion concentration by injecting different amounts of saline. We tested 0.1 cc's and 0.2 cc's by simply injecting it into the test site, and tested 0.3 cc's by dispersing it similarly to how a numbing agent such as lidocaine would be injected. To measure the lesion formed for each method, we used calipers to measure the tissue that had been denatured and turned white, as seen in the picture of the setup in the bottom right of the slide. I will pass it off to Becky to discuss our results.
The plot in the upper right shows the 2 trials used to determine the effect of initial tissue temperature on the final lesion volume. Both trials show a slightly positive trend once fitted with a best fit line, with trial 1 showing a 0.007 cubic centimeter increase per degree Celsius, or 8% of the smallest volume in the trial, and trial 2 showing a 0.015 cubic centimeter increase per degree Celsius, or less than 5% of the smallest volume recorded in the trial. Moving to the bottom half of the screen, the results from the rest of our physical experiments can be found. Only 2 experiments showed an increase to the lesion volume when compared with the control lesion: 0.1 cubic centimeter of saline and 0.3 cubic centimeter of saline when dispersed with the cannula. The other experiments featuring the novel insulation design and 0.2 cubic centimeter saline injection resulted in a loss in lesion volume. I will pass it on to Joe to talk about our conclusions and next steps.
So to wrap things up, an increase in the surface area exposed to tissue generates a larger thermal profile. Out of the 4 models designed, this is the best seen in the expandable forearm model, which is shown in the bottom right corner. To confirm these theoretical results, a prototype needs to be built and tested. Also, the presence of saline has a trend of increasing the thermal profile as well. It is assumed that the more saline is injected, the greater the profile. Although further research needs to be conducted as to how much saline is safe to inject into patients, and therefore how much saline should be used in the procedure. Finally, we would like to thank Mark and Carl for helping us out with this project, and also Dr. Goldman for his supervision.